Okay, for today's work, we're going to deal with imaginary numbers. So we basically look at the square root. Let's go up here. We're going to look at the square root of -1. And there is no such thing. We can't have a square root of a negative number. We learned that that's impossible. It's actually what we call it's not real. We're going to say this is imaginary. And we're going to talk about an imaginary number, which is the square root of -1 is an imaginary number, which we call I. So I stands for an imaginary number, square root of -1. So if I had something like the square root of -100, I break that out to be the square root of -1 times the square root of 100, which is I times 10, because the square root of -1 is I. So we write this as 10I. We put the I at the end. So that's kind of what the main part of what we're talking about today. So for this problem here, the first problem, we're just going to basically say this is square root of -1 times square root of 81, which is I times 9. So that's just 9I. Now most times we don't need to write this stuff here. We can just right away say the negative makes it an I, and that's just going to be 9I really quickly. So if I looked at something like the square root of -36, I would very quickly, without hesitation, just say that's 6I. Here it's a little trickier. It's still the same principle. It's the square root of -1 times the square root of 18, but the square root of 18 breaks down to 3 times 6, which is 3 times 2. So 3 times 3 times 2. These guys could come out. So this is I times 3 square root of 2. Or we write it as 3I square root of 2. Is typically the way it's written. Some professors would write it as 3 square root of 2 times I. I will accept either one of these two as a correct way to write it. Okay, the next problem, now we start to get a little trickier. These are the practice problems here. So when I do this one, I can do it very quickly, 5I without too hesitation at all. And this is going to be square root of 24 is, I don't need to write this out all the time, 2 times 12, which is 2 times 6, which is 2 times 3. So these guys would come together. I'd have 2I square root 6. That's what I should get for my answer. Because 2 times 2 is, one of these cancels, one comes out, and then I have 2 times 3, which is 6. And the I comes from the square root of negative. All right, now we go into this. So in this case, we're not allowed to multiply together first. We don't multiply this -49 times -64 and then take the square root. We can't multiply until we get rid of this negative. So that's going to be 7I. And this one's going to be 8I. So basically we have 56 times I squared. And now we got a little problem because I squared, we haven't really dealt with that yet. So basically, if the square root of -1 equals I, if I squared both sides, if I squared this side and I squared this side, the square root of a square just cancel, and we get -1 equals I squared. So this problem would be 56 times -1, which is -56. So that would be the answer to that problem right there. Interesting. The key to this whole imaginary number thing is realizing that I squared is the same as -1. So we're kind of going to do the same thing here. We're going to multiply these two together. And that would be square root of 2 times I is right here. And then times the square root of 6 times I. That's right here. Taking the negative out of a square root is an I, basically. And then in the green, I'm going to do this times here. So that's just going to be plus 5I square root of 2. Okay, so at this point, we look at this and say, well, this becomes square root of 2 times square root of 6, which is the square root of 12. And I times I is I squared. And the second part we can't simplify anymore. 5I squared root of 2. Now square root of 12 is 2 times 2 times 3. 2 times 2 times 3, that's 12. So when I simplify that, this is going to come out. So I have 2 square root of 3 times I squared, but I squared is negative 1. So it's going to be negative 2 square root of 3 plus 5I square root of 2. That's what we write as our answer there. Okay, let's go on to the next thing here. When I look at this, this is just practice of the same thing. We can do this quickly. This part right here becomes 3I, and this part here becomes times 4I, so that's 12I squared. I squared is negative 1, so that's negative 1 times 12, which is negative 12. This one here we're going to distribute. That's going to be 3I times the square root of 5. If I do it, well, basically it's going to be, this would be I square root of 5 times 3, which we generally write this way. Now this part's a little trickier. That's going to be plus, that's going to be, what is that going to be? Square root of 5 times I times square root of 10 times I, which is going to be plus the square root of 50 I squared. There's a few things to deal with here. The square root of 50 is 5 square root of 2 times I squared, and I squared is negative 1. So this is going to be 5 square root of 2 times negative 1. So 3I square root of 5 plus that. So now what I have is 3I square root of 5 minus 5 square root of 2. And usually what we do when we write this type of number, this is called a complex number, because it's a binomial where one of the numbers right here is a real number, meaning there's no imaginary part, and one of the numbers has an I in it, or an imaginary part. Usually what we do mathematically, we put the real part first, so negative 5 square root of 2 plus 3I square root of 5 would be the correct answer to that. Okay, let's move on to the next section here. Now, people had a lot of trouble with I to the 25th and I to the 74th, and how do we deal with that? There's a couple of things I want to start with. We'll start with I to the first equals I, because anything to the first power is itself. And then I to the second became negative 1. We figured that one out earlier, too, because negative, whatever, that would be square root of negative 1 times square root of negative 1 is just negative 1. Now, when I get to I to the third, I'm considering to myself I to the third, oops, that's not a good I, but let me make that better. I to the third is the same thing as I to the second times I. And the reason I wrote that is because I know what I to the second is. I to the second is negative 1 times I, so that's going to be negative I. And then I to the fourth is going to be, I would write this as this, I to the fourth equals I squared times I squared, which is just negative 1 times negative 1, which is positive 1. And, okay, now the question, well, what happens if I keep going? What does I to the fifth equal? Well, I to the fifth is the same as I to the fourth times I. But I to the fourth, we just figured out, was 1. So that's going to be 1 times I, which is just I. And then if I follow along, I to the sixth, I'm going to use I to the fourth because that's a nice, easy number. That's just 1. So I'm going to say I to the sixth equals I to the fourth times I to the second. 4 plus 2 is 6. So that becomes 1 times I squared. 1 times I squared, but I know what I squared is. I squared is negative 1. So this is 1 times negative 1, or just negative 1. And I to the 7th equals I to the 7th, if I'm doing the same procedure, it's going to be I to the 4th times I to the 3rd, because 4 plus 3 is 7. And that's going to be 1 times I to the 3rd. We know what I to the 3rd times negative I. So that's just going to be negative I. And then I to the 8th is I to the 4th times I to the 4th, which is 1 times 1 is 1. And I'm seeing a pattern. It goes I, then negative 1, then negative I, then I, and then it repeats itself. So now I can basically extrapolate this as far as I want to. If I have, in this case, I to the 25th, what I'm going to do is I'm noticing something that every fourth one is just 1. So if I went all the way down here to I to the 12th, that would also be 1. And every exponent that's a multiple of 4, I to that power will be 1. So what I'm going to do is figure out, based on 25, what's the highest multiple of 4 that's below that or equal to that, and that would be 24. So I'm going to think of that as I to the 24th, and then to get 25, I need one more I to the 1st. So I to the 24th is 1, because any time the exponent is a multiple of 4, it's going to be 1. Right here, and then right here, and it's going to happen again at 12, and 16, and 20, and so forth. So this becomes 1 times I, so that's just 1 times I to the 1st, which is just I. Okay, and then over here, I'll do this in I to the 74th, I have right here. Let's get the color different. I to the 74th, I'm going to think to myself, how many times does 4 go into 74? The highest power of 4, so that's going to be I to the 72nd times I to the 2nd, because 2 plus 72 is 74. And this part right here is just 1, so that's the same thing as I to the 2nd, which is negative 1. So when I look at a couple practice problems here, we do the same thing. We look at I to the 42nd and ask myself how many times, what's the highest factor of 4 that goes in there, or multiple of 4 that goes into that, so I meant. So that becomes I to the 40th times I to the 2nd. And the reason I chose 40 is because that equals I to the 40th is 1. If I wanted to put I to the 41st times I, that's correct, but I to the 41st is hard to figure out. I to the 40th is easy, that's just 1. Times I to the 2nd, which is negative 1, so the answer is just negative 1. And the same principle here, I look at what's the highest multiple of 4 for 19, and that would be I to the 16th times I to the 3rd. And then 16, I to the 16th is 1, so that's 1 times I to the 3rd, but I to the 3rd is negative I. So that would be the answer to that problem. Okay, we've got a few more problems to go over. This one here, we're going to use basically when we do addition or multiplication of operations involving I, we treat the I just like we did the X. The only difference is when we get to I squared, anytime you see an I squared, we change it to negative 1. So for this problem, I'm going to do distribute, and I'm going to say 10I, and this is going to be minus 6I squared, which is good. So now when I see an I squared right here, I say this is 10I minus 6 times negative 1. So that's 10I. Negative 6 times negative 1 is plus 6. Now generally when I write this, I want the I, or the imaginary part, to come second, so 6 plus 10I would be my answer for that one. Okay, and over here, same principle. This is going to be 5 times 4 is 20 I squared minus 35I, because 5 times 7 is 35. Now I look at I squared. I squared is negative 1. 20 times negative 1 would be negative 20 minus 35I. And in this one, I don't want to change the order around because the I already is in the second part. Okay, the last couple problems we're going to go over deal with the same principle. Whenever we multiply or add or whatever we're doing, we're going to treat the I as if it were an X. So I'm going to say 7 times 2, that's 14. 7 times I plus 7I, and I'm done with that. Now I'm going to say negative 2 times I is going to be negative 4I. And negative 2 times I is negative 2I squared. So at this point, I'm going to do just what I did with FOIL. I said 14. These two combine to be minus 3I, or plus 3I, sorry. Plus 3I, and then this is going to be minus 2 times negative 1, which is plus 2. So the answer would be 16 plus 3I. Now, a couple of practice problems for that we're going to do here. 3 times 4, that's 12. 3 times 5i is plus 15i. Negative 4 times I is minus 4i. And this is going to be minus 5i squared. So in combining like terms, we look at this and say, okay, these two combine together. So that's going to be 12 plus 11i. And this part here is negative 5 times negative 1, which is plus 5. So 12 plus 5 is 17 plus 11i, and that would be the answer to this one. And this one here becomes a little tricky. We're going to use this principle quite a bit, even in the next problem after this. 2 times 2, that's 4. This becomes minus 6i, and this becomes plus 6i, and then the last one becomes minus 9i squared. So that's going to be 4, and these two are going to cancel, minus 6i plus 6i, so it's going to be minus 9 times negative 1, because I squared is negative 1. So negative times a negative is positive. 4 plus 9 equals 13, and that's going to be the answer there. It's plain 13. And we're going to use that fact in the next problem here. This problem here, we look at this and we see a square root in our denominator, which we don't want to have, because I is the square root of negative 1. But we have a plus sign here, so we can't just multiply by I, we need to multiply by the conjugate. And the conjugate is going to be 3 minus I. It's the same principle as before. And I say 3 minus I here. So now the top of my fraction is going to be 5i times 3, which is 15i. The second part of the fraction becomes this, which is going to be minus 5i squared. Okay? Which can simplify to be 15i minus 5 times negative 1 is plus 5. In the bottom now we're going to say 3 times 3, that's 9. I can write minus 3i plus 3i. Remember, I chose this number here as a conjugate, This is always, these two will always multiply to cancel out the middle term. That's why we picked it. And then it's going to be minus I squared. So that's going to be 9 minus negative 1, which is 9 plus 1, which is 10. So this is going to be 10. This is going to be 10. Now, a couple of things about this writing as a fraction. We want to write this as what we call a complex number, which has a real part and an imaginary. So I'm going to separate that into two things. I'm going to say 15i over 10 plus 5 over 10. Now, that's still not correct because the imaginary part needs to come second. So I can reduce this fraction to be 1/2 and reduce this one to be 3 over 2. So this would be the correct answer to this problem. Quite confusing. All right, that's a practice problem. Here's another one here. Now for this one here, we're going to multiply top and bottom by the conjugate, 2 plus I. Now the top of the fraction becomes 3 times 2, that's 6. 3 times I. 6 plus 3I. That's pretty simple. There's no simplification. We're done there. The bottom becomes 2 times 2. That's 4. 2 times I. I'm going to say plus 2I. And then the inner 2 will be minus 2I. And the last one is going to be minus I squared. So that's going to be 6 plus 3I over 4. Now minus I squared is minus negative 1, which is minus a negative is 4 plus 1. So the bottom of the fraction is going to be 5. And now I don't want to leave that alone because this is a complex number. So I make that 6 over 5 plus 3 over 5I. And that's how I write the final answer. That's what you're going to be required to do as well. Similar up here, we're going to say 4 minus 3I. So this is going to be 4 minus 3I as well. And now distribute, it's going to be 2I times 4, which is positive 8I. 2I times negative 3I is going to be minus 6I squared. That's the top of the fraction. And the bottom of the fraction is going to be 4 times 4, that's 16, minus 12I, plus 12I, because these two are minus 12I, and these two are plus 12I when you multiply. And they're going to cancel. And then I have minus 9I squared. But so the top part, I squared is negative 1, so I have 8I plus 6, because negative 1 times negative 6 is positive 6. And down here, these are going to cancel, and I'm going to have 16. The bottom here would be 16 minus or plus 9, because negative 1 times negative is plus. So the bottom of the fraction becomes 25. And now I have a couple of things I need to do. First, I need to write this in two fractions. 8 over 25I plus 6 over 25. And now I have to put it in the correct order. 6 over 25 plus 8 over 25I. And that will be the final result of that.